Welcome to the Wiggin Sessions. I'm your host, Addison Wiggin. Today I have our science advisor, Ray Blanco, back with us. Ray is in the Philippines. I wrote that on Saturday, and we've had some interesting discussions about time differences over the last 2 days. And we finally managed to connect. So welcome, Ray. Thank you for taking the time. I think it's nighttime in your space.
Yeah, it's about 10 o'clock, 10. Yeah, it's about 13-hour difference from you. I'm actually a day ahead of you right now. So almost a day ahead of you. So in a couple of hours, but it's amazing that we can, reach out and get in touch, have this interview, despite the fact that we are right now on opposite sides of the planet.
Yeah, literally.
Yeah.
Yeah. So how's it going there? A big chunk of what I want to talk to you about today is the different variants and the vaccines. I want to get your opinion on what's happening. What's your experience in the Philippines so far?
So far, well, vaccine is in every conversation here. I only understand a few words of the local language, and but they say vaccine, and everybody's always talking about vaccines. Have you gotten the vaccine? Have you not gotten the vaccine? Which vaccine have you gotten? Have you noticed any changes to your health and things like that? So it's not that very different from the US. People here are very concerned about COVID-19, its effect on their health, about vaccination, about therapies. And on a policy level, the government here has taken a lot of measures, such as mask mandates. I believe public sector workers, I don't know if at a national level, or maybe at a provincial level, depending on your province, they need to be vaccinated. My wife's got several government workers in her family, and they're all vaccinated, police officers and things like that. And then they've had a pretty strict quarantine process to even enter the country. So I had to, when I arrived here for the holidays, I had to spend 7 days in a quarantine hotel, which was not fun at all, before I could finally get out and get to where I was going. So,
just to give some context, you're in Mindanao, right?
Yeah, I'm in Mindanao, which is the southern. So the Philippines is an archipelago of 7,000 islands. Luzon is the most well-known one because it's where the capital is, Manila, and it's got the highest population. The second largest island is the furthest south of the big ones, and it's Mindanao. So I'm on the east side. I'm just a few steps away from the Philippine Sea, the Western Pacific. Beautiful coral reefs, a variety of beaches, nice scenes, mountains coming down into the sea, and lots of fresh fish and seafood, which, if you like that, it's a good place to be.
Yeah. Just also for context, why are you there?
Well, my wife hadn't spent the holidays with her family for a few years. It's always been my folks back home in the US. So, we decided the COVID-19 situation had abated sufficiently that we could get away with maybe spending the holidays over here this year. So we've enjoyed Christmas and New Year's, and we'll be out of here in about a week and a half, a long trek back home to Naples, Florida. It's quite a long trip. I wish we had like Mach 5 travel or something like that, where you can get around the world in 2 hours. Would be a lot better.
Yeah, you got to get Elon Musk on that.
Yeah, he's working on it. He wants to do point to point with his rockets, right? We'll see where that goes.
So let's talk about COVID, though. The different variants. Omicron is having its way with us here in Baltimore right now. Yeah, but it's a different type of illness that you get from Omicron. So one of the questions that I have for you is the virus it has its own DNA makeup, right? And it seeks to survive, and that's why the different variants come about, because it looks for different ways to propagate its own DNA. And this variant at least the way I understand it at the moment, lives more in the throat and like the nasal passages than in the lungs. The Delta variant was in the lungs and caused a lot of problems with overflow of hospitals and ventilators and that kind of thing. But Omicron seems to be more virulent, but less harmful. I mean, it sounds terrible. Our colleague Judd had it last week, and like when I talked to him on the phone, I was like, "Oh my God, you sound like you're about to die." But it was all in his throat and his nasal passages, so it affected the way he could speak and that kind of thing. And it sounded awful, but it doesn't sound like it's as bad. How do the variants actually work? Like, what happens when the virus mutates into a new thing?
Well, it's a nonlinear, chaotic process. Mutations arise, and sometimes there's recombination where one virus will swap genetic material with another one. Bacteria do this as well. But Omicron kind of is following, these strains are kind of following a trend that has been observed in the past with outbreaks of viral pathogenic infectious disease. And that is that the virus itself, as it mutates and evolves, has the tendency to become less deadly. It does the virus no good to kill you, because when you die, it dies. It wants to spread as easily as possible. Like, I'm sort of humanizing. This is a blind process. Nobody's thinking it through here, unless you came out of a laboratory and you were engineered. But it wants to keep living and it wants to replicate. If it kills you, that's kind of not good. It's best to keep you alive as long as possible and keep you sneezing all over everybody in sight so it can spread. And Omicron is really cut out of that mold, if you look at it. So it is incredibly transmissible. It is by far the most transmissible variant we've seen to date. I mean, I've seen people compare it to measles. It's just insanely transmissible, which is bad. But at the same time, it's not nearly as pathogenic as other strains. And you mentioned it tends to just be an upper respiratory infection. It doesn't get really deep down into the lungs. So it's kind of like at the level of the common cold. And some common colds are coronaviruses, by the way. Coronaviruses, rhinoviruses, and one or two other types. So it is running in that mold, but it's got some really bizarre features. It's directly descended from a strain, B strain, that no one has seen out in the wild in more than a year and a half. And it's accumulated a massive number of mutations over that time. So it's a very weird thing. There's people wondering why this is. There's a number of options. We know it first emerged in South Africa, and that part of the world has by far the worst burden of HIV infection. So you've got a lot of people with HIV infection that are not getting their meds, so they've got weakened, compromised immune systems. It's the perfect place for a virus like COVID-19 to maybe just party on for months and months in the same host and go through all kinds of changes. So that's one possibility. Another possibility, and there was a Chinese paper that was published. They found a lot of things about this virus that strongly suggest that it jumped into us from mice. It's adapted in such a way that it can survive better in mice. And that might be why it won't go deep in your lungs, because it's too hot. It prefers cooler temperatures. That might have something to do with it. So this thing might have been sitting in mice for a year and a half. and just went through all kinds of mouse adapted mutations. We've been dealing with disease jumping at us from mice for thousands and thousands and thousands of years. So our immune systems are kind of like tuned to dealing with stuff jumping over into our own species from mice and rats and stuff like that. So,
That's why
maybe
that's why we use them to experiment on, right?
well, then there's this other hypothesis, somewhat conspiratorial. But I saw an article the other day. People are actually talking about doing this with the next outbreak of whatever it is that comes next. It could be next year, it could be in 20 years, or you and I could spend the rest of our lives and there's nothing new that'll come out and threaten the world. We don't know when these things emerge, but maybe this thing was tweaked in a lab. They used mice to do it, and it's the perfect mandatory vaccine if you think about it. Maybe they were working. I mean, the original ways of doing this is called inoculation. We're giving you a weakened virus. It's alive, it's infectious, but it won't kill you. This was what happened with smallpox, the first one. There was this English physician, and Jenner, I believe was his name, and he noted that people noticed, hey, these milkmaids that work on the dairy cattle, they never get smallpox, they never get it, and they never die. So he investigated this. They get cowpox, which is actually closely related to smallpox. It exists in cattle. It can jump to humans, but it is very weak. You'll get sick, but generally you're not going to die. So he came up with this idea that maybe, I'll cut your skin and take some scabs. I know this is disgusting, but we're talking about a couple hundred years ago here, actually longer than that. And we'll rub the scab of a cowpox infected person in it and see what happens. So it wasn't the most ethical experimentation at the time. He tried it on people, and he exposed people to smallpox after he had inoculated them with cowpox, but lo and behold, it worked. And then it was very controversial. I mean, we're talking about Revolutionary Era America, and in Benjamin Franklin's own newspaper, there's this raging debate pro and anti-vaccine, the smallpox inoculation. And it's funny how the more things change, the more they stay the same. We've seen that kind of debate in our own time.
I just wrote about it on Friday.
You just wrote about that? Oh, amazing.
The French phrase is plus ça change, plus c'est la même chose. And it just means the more things change, the more they stay the same. And what I was reading about at the time, just because I'm trying to understand how viruses work, because for the most part, if they're not around, we don't think about them, right? But I was reading about the Spanish flu, and the last outbreak of the Spanish flu was in 2009. Like, it went from being a pandemic to being endemic, meaning we just have to live with it. And there were outbreaks in 1957, 1964, and the last one was in 2009. And that one's an avian flu, right. And it mutates and combines with other avian viruses, and then they jump from birds to us.
Yeah,
no one's ever figured out how to eradicate it, so we just live with it. In 2009, something like 20,000 people died, and nobody even paid any attention, because it's like, oh yeah, you got the flu, you died.
Well, I mean, on a typical year, hundreds of thousands of people die worldwide. I'm not talking about the US, I'm talking about worldwide here. Hundreds of thousands of people die your typical year from the flu. These are estimates from the World Health Organization and others. 200,000-300,000 people. This is a typical year, not a particularly bad year. Here in the US, we could see anywhere from 15 to 50 or 60. The 50 or 60 was a bad year where we got a bad strain that people don't have a good natural protection against because they haven't seen this thing for a long time. And then, a better year might be only 10,000 people. But It's endemic. A lot of good people have been working really hard on flu vaccines, but it's extremely problematic. So the way they do flu vaccines is kind of interesting for us here in the Northern Hemisphere. So they'll look at what's circulating in the Southern Hemisphere in the summer, which is their winter, right? And places like Argentina, Australia, stuff like that, South Africa. And then it takes 6 months to finally put the vaccine out there and produce it. But it's a chicken egg process, which is laborious. But they'll produce a trivalent or quadrivalent vaccine. It'll be able to give you immune protection against 3 or 4 strains. They get this out by, our fall in the Northern Hemisphere so that you can get that shot. The problem is every year it's a different vax. And the problem is that the flu vaccine is particularly mutable. The actual genetic code for the flu vaccine doesn't have very good error correction and control mechanisms. So it mutates like crazy. And then flu viruses are always swapping genetic material. So you've got one virus in your system and you're somewhere, with ducks or chickens, and another one jumps into you. A brand new strain can emerge like that. I've been wrong. I thought the coronavirus was going to be stable enough to give us a target we could shoot at and successfully hit. But we've seen all these strains emerge after the vaccines came out. And the protection against these newer strains is far less than perfect. So, but Omicron, it's almost too good to be true. It's not very deadly. It's extremely, incredibly transmissible. If you were to engineer a COVID-19 strain that you would release out into the world and just forcibly vaccinate everybody against the bad thing and displace the bad strains, the deadlier strains, I mean, it could barely look better than Omicron does.
So let's talk about that process, though. Look, what happens from a scientific perspective when you, say you get Omicron, and then your body develops the antibodies and is relatively immune to Omicron, but not necessarily Delta or one of the other ones. What is the process in the cells? Because my next question is going to be about the mRNA vaccines. Like, what are we trying to engineer to fight it? So the first,
right. So
what happens in the body when you develop your own antibodies?
So you develop antibodies, and everybody talks about antibody, and that's fine. But your antibodies are not your only line of defense. You're just one part of your adaptive immune system. And guess what? I mean, you probably got chickenpox as a kid. You developed the antibodies for it. But if I tested you, you probably have very few, who knows, maybe not even measurable amounts of those antibodies, but you're not getting chickenpox again, not normally. Why? Because you've got other mechanisms like your T cells and your B cells, which retain memory of these pathogens, and they can mount a defense. So the thing with a whole virus exposure like that, with like Omicron, so you get a vaccine. Some of these vaccines are just single antigen vaccines. It's just the spike protein. So the spike protein mutates a little bit, and the efficacy on the actual virus, the efficacy of the vaccine goes down. Now, if you were to get exposed to the whole virus, you're not just exposed to that spike protein antigen, you're getting exposed to a bunch of other pieces of that virus, and you're developing a much more complete memory of it in your immune system, so that if you're exposed to the virus again, and hey, the spike protein is different, but look, the capsid proteins are the same or close enough, or some of the proteins on the inside are the same or close enough. So it's like, me teaching you my fingerprint exactly, but not my whole face and, the rest of me. And then I take sandpaper and I remove my fingerprint, you don't recognize me anymore. Whereas if you're exposed to the whole virus, then you know what I look like, and all that kind of stuff. So it's a more complete level of protection. So I think Omicron, I think it's endemic. We're going to see this thing rolling around for a long, long time. But I think this might be the last big wave of virus. I'm hoping that it is. And if it's not, we got to change the way we're dealing with it, because we just can't live in this state of emergency for very long.
Yeah, well, I do want to talk about like sort of the policy response and the impact on the economy.
Yeah.
We talked about that a lot in the past, and I'd just like to catch up with your thoughts on that. But with the mRNA vaccines, that's Moderna and Pfizer mostly, right?
Right.
AstraZeneca as well. Is that
I don't know. That's an adenovirus vector. So.
All right. Well, let's just take mRNA first, because that has kind of crept out into the news as like, oh, it's this beast that we created that we don't know what the long-term effects are going to be, and that's like a lot of people that don't want to be vaccinated, they use that as an example, like we're messing with our mRNA, not our DNA, but our mRNA. And what purpose does the mRNA vaccine serve in terms of the way we're talking about how the body combats the virus naturally?
Okay, so with the Pfizer Moderna mRNA vaccines, they're not giving you the antigen. Okay, so you take other vaccines, the vaccines you've already taken your whole life, from almost the day you were born, and they're giving you antigens, and something, it could be a weakened virus and an activated virus, piece of a virus-like particle. We're giving you the antigen in your body so that your body attacks it, recognizes it, and remembers it. So with the mRNA vaccines, they're not doing that. They're actually very cleverly, on an RNA molecule, they wrote the code for the antigen. In the case of the Pfizer Moderna COVID-19 vaccine, the code that they wrote on the RNA is the code for the spike protein on the virus. So it's like a piece of viral code that we've synthesized. And then we've taken the way of when we inject it into your body, there's a delivery mechanism that will get it into your cells. Now, what happens when the mRNA is in your cells is that your cell doesn't know the difference between its own mRNA or someone else's mRNA, which is how the virus replicates, by the way. So your cell takes that mRNA, it reads that code or that blueprint on that molecule, and then it goes ahead and manufactures what the code codes for, which is the spike protein antigen. So the big difference, again, between the mRNA vaccine and traditional vaccines is that they're not giving you the antigen directly. They're giving you a snippet of code that your body takes and uses to make the antigen.
I think that is exactly what freaks people out. Is that
right?
Code. It's genetic engineering.
Well, it doesn't make any lasting changes to your nuclear DNA or to your mitochondrial DNA. It's upstream of that. So you've got your DNA in your cell, it gets changed into mRNA, and then the mRNA gets processed and turned into a protein. I mean, that's the way biology works. But the DNA stays there forever. We'll just use the word forever. And when your cell divides, a copy is made for the new cell. But the mRNA is really just a blueprint courier between the DNA and the ribosome, which is the factory that makes proteins. So they're just putting in some couriers with blueprint copies of that they made in a lab. A lot of people have a problem with that, and it's an interesting thing. We've got really, no approved mRNA therapies, to my knowledge, I could be wrong, but to the best of my knowledge, there are no approved mRNA therapies. So we've got no long-term data of this modality in human beings. And all of a sudden, we're rolling it out to hundreds of millions of people. It's reasonable to have a little bit of concern with that. I mean, it's been very safe in the lab and stuff, but it isn't unreasonable to be concerned. And that's why every person, I don't believe in the mandates. Every person should weigh the risk and weigh the benefit themselves, and be allowed to make their own decision, and be allowed to hear both sides of things, not this censorship where they're taking experts off of social media that are just trying to share the bad part of it with you. I mean, to make an informed decision, you need to be able to have access to the information. And if only hearing one side of the story, then you don't have informed consent. So yeah, it's a new thing. There's no long, vaccine can take up to, it could easily take a decade to go go through clinical trials and to build a database on it and to study its long-term effects in humans. And we've got this situation where we've got, hundreds of millions of people who have taken this vaccine now after just a few months of short-term data. So, we'll see how it goes.
Yeah. Well, I've taken, I got the Moderna, I got 2 shots of that, and then I got the booster as well.
Right.
What's the point of the booster? Like 2 shots, like how does it work? Why is it a progressive thing? And the other thing that's going to happen is, like, in the spring, they're going to say you need another booster. It's like, I get very cynical when I keep hearing from, Dr. Fauci that I need another shot. Like I start going, wait a minute, every 6 months we have to, pay, the government has to pay Moderna to put a needle in my arm.
The problem is that the antibody counts drop. So they got to give you a booster to get that back up again.
So what's the difference between the booster and the second shot? It's really
the same shot. You're getting another one.
So they just called it
back shot. So, there's risk with the shot. Even we know the risk is higher with the second shot than the first shot. I mean, one of the major issues, especially in younger males, is heart inflammation, right? Myocarditis, pericarditis.
Mm-hmm.
And it's possible that each subsequent shot could make the situation worse. And then you've got, the adenovirus-based vaccines, which are DNA vaccines, by the way, Johnson & Johnson, AstraZeneca, and those are, the risk with those is blood clotting, right? Early in women, it's higher. Women are at the highest risk of it. So they're not risk-free. I got the Johnson & Johnson because it was one and done, and I needed to get out of the country for a while. And the myocarditis risk, I don't know, psychologically, it terrifies me that I'll get a heart attack or something.
Right.
So they haven't seen that.
And explain the difference between the mRNA vaccines and the Johnson & Johnson one.
Well, it's a very similar thing, but one step removed from the manufacture of the antigen. So the Johnson & Johnson and AstraZeneca vaccine, what they're giving you, they're giving you an adenovirus. The virus is just a little machine designed to infect your cell and drop a little piece of DNA inside. Now, this is not your nuclear DNA. This is not your mitochondrial DNA. It's just floating around inside of your cell. It doesn't last forever. Okay. And then your cell reads that DNA, makes the messenger RNA, and then the messenger RNA goes to the ribosome. So I said it's one step removed, right?
Yeah.
Instead of giving you an RNA, they're giving you a DNA that gets read and then converted to an RNA, which then goes to the organelles, the little protein manufacturing plants in your cells that make the antigen. So again, they're not giving you the actual, they're giving you a virus, but the virus is just a little machine meant to bring the little piece of DNA into your cells. And then, so they're not actually giving you the antigen. They're giving you the code to make the antigen, and your cells naturally make it. Now, why do the mRNA vaccines have this issue with heart inflammation, and the adenovirus ones don't? I don't know. It doesn't, I don't know. I mean, and then we've got other vaccines coming out, but that are more traditional, which had they been available, I probably would have preferred. There's the Novavax vaccine, which is protein subunit vaccine, they call it. Novavax themselves call it a viral-like particle. So they're actually making a little piece of virus, all right, and they're injecting the little piece of, the antigen itself, and they're directly giving you the antigen. So there's none of this translation from a piece of genetic code. It's just, we're giving you the antigen straight up.
That's more like a traditional vaccine.
Right. And the safety data in the clinical trials, it looks really good. Of course, we haven't had hundreds of millions of people injected with it yet, but it's been approved here in the Philippines. World Health Organization emergency approved it in December. It's been approved in India. The Serum Institute is going to be making, hundreds of millions of doses of this stuff. I haven't checked the news today, but maybe there's news today that they finally went to the FDA for an emergency use authorization. They're Johnny-come-latelys, and honestly,
We're still talking about Novavax, right?
Yeah, Novavax. They're Johnny-come-latelys. Omicron might make this whole thing moot if everybody's got that level of protection. And, you're hearing it on the policy side. The people running the country they want to throw in the towel already. They couldn't beat it. It beat them. So they want to change the story. We got elections coming up here this year. We got to change the story. We got to dial it down. Omicron gives them a perfect excuse to do so, because it's not putting a whole heck of a lot of people in the hospital. Most of those hospital cases are people that went in for X and they happen to have COVID at the same time. So they were hospitalized with COVID, or they tested positive. I mean, they might be asymptomatic. All right. They tested positive, and so they're hospitalized with COVID, but not because of COVID. So we're starting to hear the regime changing their narrative now, because, and a lot of this is that you can't admit that you've made a mistake. You have to be all knowing all the time. The government can't admit that it's screwed up, that maybe it's recommended, the masks didn't really help. The vaccine didn't stop infection and transmission, although it helped with severe disease. So we got to give it that. So everything, they've been wrong about almost everything. But these people can't admit they're wrong, because then they become, they think they'll become illegitimate or delegitimize their governance and the bureaucracy. These people got to keep their jobs. Fauci's the highest, I heard Fauci's the highest paid guy in the US government, which is crazy. He makes more than the president. So they can't change the story. They can't say we were wrong, we screwed up, we made a mistake. I think people would accept that. Most reasonable people, hey, this was an unprecedented situation. We had our best and brightest people work as hard as they could on it, but it's something we've never faced before. Mistakes were made. Man, I respect you guys for standing up and saying, we're sorry, we screwed up, we need to change our policy because this didn't work. It's like Eisenhower.
Isn't that going? I'll let you make the Eisenhower comment in a second, but isn't that exactly what's going on with the CDC right now? That people are losing confidence in their guidance because they won't say that they're wrong.
And the FDA as well. So, we need a stand-up guy like Eisenhower. So ahead of D-Day, he gave this great speech to the troops. But, you know, war is like this virus. You don't, you know, it's like Mike Tyson said, everybody's got a plan till they get punched in the mouth, right? Or in the face or whatever. We had a plan for D-Day, but the enemy's got plans too. And the outcome is never certain in war. You know, when they're invading the amphibious invasion of France. One of the greatest things about Eisenhower, he had a second speech written, and he had it in his pocket. And in that speech, he had written that speech ahead of D-Day in case the invasion failed. And in that speech that he wrote, and it's in like the National Archives, it's handwritten. He took full responsibility for this horrible failure that would have killed probably tens of thousands of Allied soldiers. Okay, he said it was not the blame of the brave soldiers and airmen and sailors or of any of his subordinate officers. The blame lies solely on him as the Supreme Allied Commander. He's like, he didn't quite fall on his sword, but you know, the guy, you know, what kind of leader? We have no leadership like that today, you know?
Yeah, I just watching the way that they're trying to change the narrative now. I think it's exactly what you're saying. They're just gearing up for the midterm elections. They're trying to keep power, democratic control of the House. And that's it.
Yeah.
And so they know that they're losing the war against the virus, because the virus, especially if it goes endemic, it's just something that we have to live with. So, but they won't stand up and say that.
You know, so I know you write a lot about economics and the foolishness of the Federal Reserve and our funny money, and they think they're smarter than the markets. The markets are smarter than them. Well, guess what? It's the same thing with nature. The virus has proven to be smarter than our smartest people. And they've tried to exert this, in my lifetime, unprecedented level of control over society to try to stop this invisible little thing that doesn't even have a brain. And guess what? The virus won.
And continues.
And it continues, right? The infections, here the infectiousness is not that bad yet. It's going to come. I've already told all my relatives, all you guys are going to catch it.
Yeah.
Every single one of you. You know, and they're horrified. I said, it's not that bad, but you're going to get it. And in the US, it looks like everybody's getting it now. I haven't gotten it yet. Maybe I'll catch it on the flight home. We'll see what happens.
Yeah. Well, good luck with that.
Yeah.
I have chosen to hang out in my kitchen and my basement and try to keep people out of the house.
Yeah.
But you know what? I'll probably get it at some point too. So let's talk about investing in this a little bit. Is it still a good play to buy Moderna or Pfizer? One of my favorite stories of this is Warren Buffett bought 51% of Pfizer in April of 2020.
Smart man.
But he does his homework and he knows a lot of people. So yeah, that's one of the things that kind of runs against you if you're an individual investor. There's guys like Buffett didn't buy 51% or whatever. I don't know what the exact number was, but he bought a huge share of Pfizer before anyone knew that Pfizer was going to come out with one of the predominant vaccines.
Well,
Gates has been on the vaccine narrative for since the late 90s, right? Yeah. So those guys are like, oh, this is the thing that we're gonna put all our money into. How do individual investors consider where they're going to put their money when you've got a couple of the richest guys in the world controlling the narrative?
Well, on the one hand,
it's worth it. It might even be just say like, all right, well, they got that, and you put your money elsewhere. And I'm asking you specifically because you're looking at investments. I think you picked Moderna way early, and then you got out when you got some money.
Yeah, well, Moderna was a pure play. right? I mean, Pfizer's big. It was big before the epidemic, right? The pandemic. Whereas Moderna was, you get all of it if they succeed in this one smaller, much smaller company. So no, you're never going to be able to compete with a Warren Buffett or a Bill Gates. Not in terms of intelligence, but in terms of access. They have access. They know people. They have a lot of money. People come to them. Things like that. Our typical person listening in will never be able to. That doesn't mean you can't beat the market, be ahead of the market, identify valuable trends, and jump on them and make money. Top of that, Gates and Buffett are like dinosaurs. They can move, but not very quickly. It's a lot easier to invest $50,000 than $5 billion in some small company with tremendous potential. Look where Warren Buffett put his money. Pfizer, one of the largest, if not the largest pharmaceutical company in the world, is definitely in the top 5. So he didn't put it in a Moderna, which would have been relatively small at the time. So what do you do now, right? That's the big question. I feel like Omicron might be, I was talking about the Johnny-come-latelys. I like Novavax. I do like Novavax, but I'm getting a sinking feeling that this might be the end of the party, that Omicron is going to be the forcible vaccine that's going to hit everybody. And it's going to finally, just make this thing, turn this thing into a dull roar that we just got to deal with like we do with the flu. Yeah, there'll still be a market for it, but it won't be the market that we had during the pandemic phase. I mean, I was reading analyst estimates from last year. These were probably made before Omicron hit, that Pfizer, Moderna together, we're going to do like, I don't know, $93 billion in vaccine sales in 2022. That is just mind blowing. That's a lot of money. So how do we, I think Omicron could be just a divine providence intervening in human history, finally put us out of our misery with this situation that we've been dealing with.
What about treatments then? Do you see any treatments?
Oh,
like after you get Omicron, you go and you take medicine or whatever.
Well, I see a smaller market there as well. Omicron is not hospitalizing as many people, but it's doing it in a hurry because the spike is, the shape, the area under the curve might not be bigger or smaller, it might be the same, but the curve is very sharp. So we'll blow through these Omicron infections. They're saying it's January 10th, we might be a week away from peak, and it's downhill from there. So what does that mean for the market for therapeutics? And some very interesting ones have been coming out. Although we've been having shortages of other things. I mean, it's a ridiculous situation. I do like biotech right now a lot. Biotech utterly pummeled last year. When I say biotech, I mean small cap developmental stage stuff that isn't necessarily generating any revenues yet, just beat to hell. And I'm looking at some sort of a reversion to mean now. I mean, the underperformance compared to the S&P 500 for the XBI, which is the Standard & Poor Biotechnology Index ETF, was something like 50%. Unbelievable. And I mean, there was good reasons for that, a variety of reasons for that. I think.
Well, everything turned towards the pandemic, right?
Yeah, but they did really well up until spring last year. In fact, February last year, XBI hit all-time highs and been downhill since. Now, the interesting thing here is that there's a lot of factors. There's the Democrats took over the White House, took over Congress. They want to put some sort of price control on drugs, drug negotiations with like Medicaid and all that, which is bad for a lot of drugs, but I don't think it's bad for a breakthrough new drug. They're not going to do that. So it's not going to hit revenues. If I invent some new cancer cure, I got a little $5 billion biotech company. There's the fact that it's really hard to run clinical trials for cancer, let's say, in the middle of a pandemic. It's hard to recruit people unless you're recruiting for COVID. Very, very difficult. Maybe the COVID-19 investing hype ran out of gas last year, and that didn't just hit COVID-related companies, it hit the whole sector. That's very possible, but I'm looking at the XBI and stock, those types of stocks, and I think they've got a lot of opportunity this year. One particular group, the gene editing companies, are just in very bad shape. We've got JP Morgan this week, the biggest healthcare conference of the year, could really change the tone. I said gene editing companies, so we're talking about stuff like, I'll throw a few names out there: Sangamo Therapeutics, Editas, CRISPR. Everybody's heard about CRISPR, right? A big pharma company this morning, I forget the name, I don't have it here in my feed. They bought a gene editing company today, Beam Therapeutics, I think is the name. I don't know what kind of a premium over the closing price, but it's probably pretty hefty. So you own some of these high quality small biotechs. I think gene editing names you should really pay attention to them this year. I think you could outperform this year. And then the other side of things is, I think everybody's looking at.
Before you move on, just to be clear, you're saying they got beat up in 2021,
right?
But that makes them attractive because they're still good companies.
They're still good companies, and they're really attractive now as buyout candidates, because big pharma, what they build is perishable from a revenue standpoint. I invent this new whiz bang therapy, really good stuff. And I've got a cash cow, money making. I'm printing cash for 20 years, and then it goes off patent, and now that's over. So they've always got to be replacing aging drugs with new drugs. And yes, they do this with in-house development. So they do develop their own drugs. They have their own R&D and all that. They'll partner with small pharma, small biotech, or they will just buy them out. So you've got a metabolic disease franchise or a oncology franchise. You'll buy some sort of a metabolic biotech or a cancer oriented biotech, and you'll add them in, and you absorb all their intellectual property, all their clinical programs, and all their scientists, and then you can build your pipeline so that you can keep on making money and keep that revenue tap flowing, because old drugs are cheap drugs. They should be cheap.
Yeah.
Unfortunately, they aren't always.
But that's one of the things that makes the smaller biotechs attractive, especially if they've been beaten down, because then they could be takeover targets, they could be partnership targets, or they could, like Moderna did, they could just go up against the big guys and suddenly they're one of them. There's
what an
example. Different ways. Yeah. All right. Well, let's just remind people how they can get your ideas on all these things. I know you've got other irons in the fire with like 5G and a few other things, but since we've just been talking about the pandemic and biotech, like what's the best way for readers to keep up with you? Catalyst Trader is one.
Yeah, so we've got Technology Profits Confidential, and we've got right now Catalyst Trader. So Technology Profits Confidential, we're profiting off the biggest trends in technology and biotechnology, which is what we've been talking about today. And then our Catalyst Trader newsletter is all about making profits on just pivotal catalysts. And these are many different kinds of companies, many industries, including biotech. I love biotech catalysts. So if you like what you've heard today, guys, you can look me up, Technology Profits Confidential and Ray Blanco's Catalyst Trader.
Awesome. Well, thank you, Ray. Ray, I really do hope that you make it back to Naples without getting Omicron.
Me too.
That's a long time to be in a small tube in the air.
Yeah,
People.
that sure is. All right.
Well,
Good
good luck.
talking to you guys.
All right.